Hello friends, my name is Rakash and today we are going to solve advanced geometry. This problem is very similar to the problem which you have faced in CHL mains on 17th of Feb. You had over there 4 squares in a circle, and here I have taken only 1 square because I just wanted to simplify it for you. Still this question falls into the category of advanced geometry. So what exactly is the question is, there is a circle, inside it there is a huge square, area of which is given as 144 centimeters square, and there is a small red square, which area of which is 16 centimeters square. What exactly we have to find is, we have to find the radius of the circle. So to find radius of the circle, what exactly are we going to use? What concepts are we going to use? You might be aware of the fact that radius of circumcircle of a triangle is given by the formula A into B into C upon 4A, where A is the area and ABC are the sides of the triangle. I am going to use this concept over here. This might be unique. I mean, few people might be knowing this or might have solved it using this formula. But using this concept makes it quite easier, and it becomes very easy to solve many of the problems related to this question, this particular question, and many such problems related to circumcircle. So how are we going to use this radius of a circumcircle over here? What I'm going to do is, I'm going to name this corner points which are common to circle and square, A, B, and I'm going to name this top vertex of this smaller square as C. Okay, now that I've got the extremities of these of the squares, and these 3 points A, B, C, all 3 points lie on the circle. So now I can join these 3 points, and what I'm going to get is a triangle. I'll show you. What I'm going to get is a triangle. Here you go. Okay, so I've got a triangle over here. Now what? How to find the sides A, B, C, and how to find the area. Okay, so before that, I want to let you know that since this is a square and this is also a square, this angle is 90 degrees. So if I extend this over here on this line, this particular line, it will be perpendicular obviously because this is parallel to this. So this becomes your height. So this becomes your height. I name this point as M. Okay. So what I've got is, I've got a triangle, I've got the height and the base. Now, can you tell me what exactly will be the value of the height, that is MC? What would be MC? It is clearly, since area of this smaller square is 16 centimeters square, that means the side of this square is 4 centimeters. So this part, this upper part is 4 centimeters, and this lower part is nothing but the square side of the square of this black square. I'm sorry. So area of the black square is 144 centimeters square. So the side of the black square becomes 12 centimeters, and side of the smaller red circle becomes 4 centimeters. I'm sorry for my bad handwriting, but you can get the concept over here. So I got the value of, let me rub this off. I got the value of height MC is equal to 4 plus 12, that is 16 centimeters. Okay, I got the height, and now base AB is nothing but the side of the black square, which is nothing but 12. So base, this is height, base AB is equal to 12 centimeters. Okay, then we are done, then we are almost done. Now we have to find the area of the triangle ABC. I'm naming it over here, is equal to half into base, which is 12, into height, which is 16 centimeters. So what I get is 96 centimeters square. Note it. So area of the triangle ABC is 96 centimeters square. So I got the A part, okay, in that formula. Remember that formula? R is equal to ABC upon 4A. So I got the area of the triangle. Now comes the tougher part. How to find the sides of these triangles? Not that quite tough. I'll tell you how to do it. So here we are going to use Pythagoras theorem. I hope you're noting down the values over here, okay? Because I'm rubbing it. So you please better note down the values and the full solution, and be in sync with my video, okay? So that you don't have to pause my video in between. But still, you'll have to pause because you cannot, go at a stretch and solve these. So where was I? I had to find the sides. So first let us see what exactly AM is, because since we are going to use Pythagoras theorem, so to find AC I need AM and MC. We know MC is equal to 16. I calculated just few minutes before, 16 centimeters. But I want to know AM. What would be AM? Okay, for that, see this smaller square, red square is of side 4 centimeters. So if I drop it over here, or suppose there is a line AB, it is the side of this square, black square, and I drop these 2 points, these 2 extremities of the smaller red square over here. So this is 4. The remaining part is 12 minus 4, that is 8. So this plus this is 8. That means these two would be 8 by 2. That means this is 4. This is 4. Okay. So A and B can be divided into 3 parts of 4 centimeter each. Okay. Then how do we find AM? I'll tell you. Since this, what I told you, that if I draw these 2 points, M is over here already. If I extend this point over here, so this becomes 4. This becomes 4 and this becomes 4. So it has been divided into 3 parts. So what exactly would be AM? Or AM would be 8 centimeters and BM would be 4 centimeters. Now what we have to find is, we just have to find AC and BC. So you will apply Pythagoras theorem. So AC square is equal to AM square, which is 16 square, which is 256, plus and MC square, which is 256, and AM square, which is 4 plus 4, that is 8. 8 square is 64. So 64. What we get over here is approximately, not approximately, we get exactly 320. So the value of AC will turn out to be 8 root 5, I guess. 8 root 5. 32 into 264 into 5. So 8 root 5. So we got AC as 8 root 5. I'm writing it over here like this. 8 root 5. Similarly, we can find the value of BC. Finding the value of BC becomes easier again, since we know BM. So BC square is equal to 4 square, again 16, plus this 16 square, MC square, which is 256, which is nothing but, I guess, it would be 272. Okay, so what we get BC as 272 can be written as 16 ones are 16 112 8 24 24, which is nothing but 4 root 17. So I got the value of BC2, which is 4 root 17. I don't have space over there to write. Okay, so you just noted that the value of BC is 4 root 17. Let me just mark it over here. 4 root 17. BC. This is BC. Okay. So guys, I think we are done over here with this question, because we've got the value of area of the triangle. Which triangle? The triangle which is inside the circle, which I'm in the triangle which this circle is circumscribing. So we'll use the formula of radius of circumcircle, which is nothing but ABC upon 4A. Okay, so tell me the value of A. A is, suppose this. So AC, 8 root 5 into, what is the value of B? The value of B is 4 root 17 into, what is the value of AB? That is the third side. It is 12 upon 4 times of area. What was the value of area? It was 96, I guess. So I'm writing it 96 over here. 12 ones are 12 eights up. 8 gets cancelled. 4 get cancelled. What is remaining? What is remaining is root 5 into root 17. So our final answer would be R is equal to root 85 centimeters. We got the value of radius. So I hope you guys have paid attention to the critical points in this video. What was the basic funda over here? I was given with only these two squares. I was not given with any of the other figures like this triangle. I had to construct it. So you'll have to think. You'll have to push your brain a bit, because these are not direct geometry questions. These are indirect geometry questions. But there are many methods to solve this question. But I choose to be simple. This particular way, in my sense, is the best method or the best way to solve it. Because you just construct a triangle and use the simple formula for radius of circumcircle. So this saves your time, because if you go for other methods such as similarity, you'll also get other methods like you'll have to construct a triangle and then apply similarity and all. That becomes tedious. I hope this is clear, guys. I'm going to again share some of the beautiful geometry questions, and do not forget to like, share and subscribe my channel, because this is my first video lecture. So I would be very happy if you guys really support me. There's a lot of stuff for y'all, and I've been literally working for a few months or so to create some beautiful content. I mean, I have around 100 or 150 beautiful high-level quant questions. I'm going to solve it, and provide it to you via this video. So thank you for watching this video, and since this was my first video, I hope you'll forgive me for all this stammering and all, which I'm getting it right now. Thank you so much, guys.